Welcome inside iPhone 17 production, where every micron matters and every unit gets tested in seconds.
Today we're following one iPhone 17 batch, from receiving to final pack out.
Everything starts with traceability. Every pallet is scanned into the line's lot history.
High-value parts arrive sealed. Wafers, chips, sensors, kept closed until controlled handling. Incoming QC confirms seals, desiccant, and humidity indicators before anything enters storage. From here, every tote is stored by location and pulled only when the line calls for it.
IQC samples each lot. If anything's off, it never reaches the assembly lines.
They verify markings and packaging integrity before these parts are authorized for build.
Critical dimensions are confirmed here: camera pocket, button cutouts, and board mounting points.
Once released in MES, the same lot can be pulled to the line. No manual guesswork.
From storage, totes move automatically to kitting, still sealed and fully tracked.
Pick to Light ensures each kit matches one SKU. No mixed colors, no part substitutions.
Frames are tracked the same way as chips, each one tied to the batch from the start. AGVs keep material moving on schedule, without breaking traceability or safety lanes.
This is where the graphite titanium enclosure starts: machining, inspection, and finish control.
Robotic loading keeps billet orientation consistent and prevents handling damage. High-speed tools carve the frame pockets, while coolant controls heat and chip flow.
These final passes define the features you'll see on every finished graphite titanium enclosure.
Unloading is automated too. Frames stay protected and contained for the wash stage.
Aqueous washing strips coolant and fine chips, so the finish stays clean and consistent.
Dry, clean surfaces matter. Any residue can ruin adhesion and coating later.
Deburring removes sharp edges and keeps the frame ready for sealing surfaces later.
Bead blasting levels the surface so the final graphite titanium look stays even.
Before coloring, frames are chemically cleaned so coatings bond and don't blotch.
Color is measured, not guessed. This station flags any drift before assembly ever starts.
This laser mark ties the frame to the same batch ID all the way to packaging.
A vision system grades every mark, so tracking never depends on manual reading.
Carriers prevent finish damage, keeping every frame identical by the time it meets glass.
With frames ready, the factory runs parallel lines, glass prep, and electronics build. Ceramic shield glass starts as sheets, cut and finished under tight control to avoid micro cracks.
The cut pattern is repeatable, same dimensions every time, so the seal line stays consistent.
After scoring, the blanks are separated and placed into carriers to protect the edges. Edge finishing removes microchips and sets a consistent radius for strength and sealing. Strengthening is done in a closed system, with strict handling to protect both the glass and the team.
Rinse and dry ensures the surface is clean before coatings and optical inspection.
This system flags chips and scratches early, before the glass ever reaches assembly. From inspection, the glass stays protected to keep particles off the viewing surface. A controlled coating step adds the final surface properties without contaminating the glass. A last visual check confirms the coating is clean and uniform before packing. Carriers keep every glass piece separated and matched to the same production lot. Automated delivery keeps glass protected and timed to the build schedule.
Now the electronics. This line builds the iPhone 17 logic board from bare HDI panels.
Solder paste is printed through a stencil, depositing the exact volume for each pad. SPI verifies paste height and alignment, preventing hidden solder defects later. Pick-and-place robots mount thousands of parts per hour, each verified by onboard vision. Larger packages are placed with higher accuracy, so ball grid and fine-pitch parts seat correctly. Reflow profiles melt the solder, then cool it in a controlled ramp for reliable joints.
Boards cool on the line before any inspection or test, keeping joints stable.
Shield frames and connectors are added in later passes, using tooling designed for metal parts.
A second controlled heat cycle solders shield frames without overheating the rest of the board.
Buffers keep spacing consistent, so inspection machines see every board the same way.
AOI catches missing parts, misalignment, and solder bridges before electrical testing.
X-ray confirms BGA connections you can't see from the surface. If a board is flagged, rework happens in a dedicated cell with controlled heat and alignment.
Cleaning removes residues that can interfere with testing and long-term reliability.
ICT checks continuity and component health before the board becomes a phone.
Functional testing powers the board and verified key communications before software loading.
After hardware passes, each board gets firmware and a secure identity, fully logged to the lot.
Flashing fixtures program multiple boards at once, using verified images and automatic checks. Serialization links the programmed board to the same lot history used for frames and glass. Now the logic boards are ready, protected, labeled, and queued for the main assembly lines.
Next up is camera build, alignment, bonding, and calibration, all under cleanroom control.
Sensors are unsealed only under laminar flow, then scanned into the camera build cell. Adhesive volume is metered and verified by vision before any lens is seated. Robots place the lens stack with consistent force and orientation, checked every cycle. A closed UV cure locks the adhesive without exposing operators or the optics to dust. The lens assembly mates with the stabilizer actuator. Then sensors verify the seating height. Active alignment tunes focus and tilt by measuring real image quality against a collimated target.
Once the image is tuned, the station locks the geometry with adhesive and a controlled cure.
Calibration confirms stabilization response and optical geometry before the module is released. The protective sapphire cover is bonded and verified, then the module is packaged for final assembly.
Display build starts with OLED panels handled in cassettes to prevent flex and contamination.
Alignment cameras register the touch layer, then vacuum lamination prevents bubbles. A pressure cycle removes micro bubbles, so the display looks uniform under bright light. A quick interconnect test confirms the flex bond before full screen testing. Uniformity is measured under controlled lighting. Any defects are caught before assembly. A robotic probe checks touch response across the panel, so sensitivity stays consistent. Displays are protected in rigid carriers, so they stay flat and clean until final assembly. Battery assembly uses insulated handling and strict checks to prevent shorts and ensure consistency. Every cell is screened for voltage and resistance before it's allowed into a phone pack. Cells and insulation are seated in a controlled fixture to protect tabs and prevent shorts. Tabs are welded inside an interlocked enclosure, with extraction to keep the area clean.
The protection circuit is mounted with controlled torque, so connections stay stable under vibration.
Sealant is dispensed in a controlled pattern. Then the insulating cover is placed immediately.
A controlled cure sets the sealant without stressing the cells.
Safety testing confirms insulation and protection behavior before the pack is released. Each pack is labeled and scanned, so it can be matched to the same phone build history.
Speakers are gasketed and inspected to support consistent sealing and sound performance.
Haptics are tested for electrical values and response, so the feel stays consistent phone to phone.
All sub-assemblies are staged by scan and light guidance, so the final line builds one exact SKU.
Final assembly starts with the finished graphite titanium frame, carried station to station in locked fixtures. Small hardware goes in first, antennas and brackets, each fastener verified by torque. Speakers and haptics drop into dedicated pockets, then an automated head torques the full pattern. The logic board is placed by gantry and verified by vision before any flex cables are connected.
A measured TIM pattern supports heat transfer without contaminating nearby connectors.
Cameras are seated in the pocket, then flex connectors are pressed with controlled force to protect pins.
Front sensor modules are aligned in a dedicated recess, using controlled adhesive and fixture alignment.
The battery drops into a guided pocket, then its flex is routed and connected without stressing the pack. A continuous perimeter bead is what makes sealing possible, and vision checks it before the screen goes on.
The screen is placed by robot, then pressed to a controlled height so the seal is consistent.
With the internals enclosed, the back glass is placed and pressed to complete the housing stack. Torque tools log every critical fastener, and vision confirms screw presence before the phone leaves assembly.
Curing stabilizes the seal adhesive, so leak testing is meaningful and repeatable.
A camera verifies seal continuity, so defects are caught before water resistance testing.
Pressure decay testing checks the seal without water, measuring tiny leaks in seconds.
At end of line, the phone powers up in a fixture and runs a quick baseline diagnostic. Shielded RF testing confirms antenna performance and radio stability before pack-out. Motion sensors are calibrated in a known orientation, so measurements stay accurate in the field.
Even after module calibration, the assembled phone runs a camera check against standard targets.
The phone runs an audio sweep in a sealed box, measuring speaker output and microphone response. A sensor measures the haptic pulse, confirming the feel is consistent on every unit. Vision inspection checks gaps, finish, and glass alignment under controlled lighting. A jig and roller apply the protective film straight and bubble-free, ready for packaging. Before boxing, the phone and box label are paired by scan, so the records match exactly.
The phone sits in a molded fiber tray. Then the box is closed with the matched label.
A tamper seal is applied and checked by vision, so the package stays secure in transit. Retail boxes go into master cartons, and weight checks catch missing units instantly.
Palletizing and wrapping keeps cartons stable, labeled, and ready for warehouse movement.
That's the full flow. One tracked iPhone 17 lot. Built, tested, sealed, and ready to ship.